right, welcome everyone. Omnitech provides core IT services including Nagios systems, and our next presenter is going to teach you guys some tricks. How about a nice big round of applause for Leland Lammert?
Thank you, sir. It's nice to be here. I've never been to a Nagios conference before, but we've got a great group of guys, and I've learned a heck of a lot at the conference. I hope you guys have too. We solve a lot of unique problems for companies. We specialize in core services, including Nagios installations. And I came up here, proposed to talk to share some of the tricks with you, because the whole point of the talk is to create a heterogeneous environment across multiple platforms. Was that my shill in the crowd? All right, basically, when you're installing Nagios on a client machine, you can have different OSs, you can have different connections, forward connections, reverse connections. We deal with a lot of remote servers, so there's 90% of the time there's a firewall involved. There's politics involved, there's remote IT services involved. It's a blooming nightmare. So this particular installation I'm going to talk to most about, we've got 90 servers scattered all across the country. And of those, about 75 are at remote locations on other client installations. So we can't deal with firewalls. You know, we don't own them. So the biggest problem I had was how to create a stable environment for Nagios that would work cross-platform, primarily Linux and Windows, although it also works on Apple, also works on BSD and most other Unix platforms, and a standard installation procedure. We don't want to use agents primarily for simplicity. You know, typically we got one server out there in a remote location. That server is, again, Linux. Nowadays there are a lot of Windows servers. We need a standard installation that the tech can do before they ship it out. So we want it to be standalone, or not standalone, but simple, something the tech can do at any, with any machine. If you're doing a check on a remote machine, if it's inside, how many of you deal with outside firewall issues? Okay, a good percentage. The issue is inside the firewall, if you're in your corporate environment, you've got control over the firewalls, you know who the provider is, you know who manages it. Somebody across the cube or across the room can punch a hole in that firewall for you if you need it. If you're outside the firewall, though, outside your firewall and outside a firewall on a remote machine, there's at least one other major player that comes into the picture. In this case, a owner of that remote machine, a customer I'll call them. And I don't want to have to call their IT guy and say, hey, we need to punch a hole for our Nagios server so we can monitor your machines. A, they're going to look at you cross-eyed. B, they're going to want their boss to approve it. It's going to go up the chain. It's going to create a lot of ripples in that remote organization. So there's a solution. We standardize on SSH. SSH is a standard protocol. It's available on any servers, and I'll show you how it's even standard on a Windows machine. With SSH, a forward connection works fine. Inside the firewall, you can SSH to any machine, set up your key pair, you're good to go. If you're going to a machine outside the firewall, we standardize on SSH tunnels. Anybody use tunnels today? Okay. Basically, that tunnel means the remote machine calls home, sets up an SSH connection to the Nagios server in your environment, and flips a switch on the connection that says, okay, now that I've connected, I want to route traffic from the Nagios server back to me. It's called a reverse tunnel. That's the whole key to the solution. If you do that, then active checks can be used on all systems. You can use agents if you want, but with an SSH tunnel, you can use active checks. There's no agents involved. There's no installation procedure involved other than setting up the tunnel and copying a tarball or a zip of plugins out to the proper location on a remote server. The best advantage I've seen, and one that I like, is I can SSH, I can connect to that remote machine at any point in time and do anything I need to from an admin standpoint. That is the big key you do not have with an agent. I don't know if NCPA, the new one that they're talking about, is going to have capabilities like that. It looked like it might. But this is available today. It's available on all platforms, and there's no software installation involved other than setting up the tunnel. So today what we're going to talk about, secure shell, a little bit of background and history for those of you that haven't seen it before, how an SSH connection is established. It is very secure to set up, and it is moderately secure in operation. The authentication is the critical part. You want to make sure that the server you're talking to is the same one you talked to last time. There's no man in the middle. And you want to also ensure that your user credentials are valid to establish that connection. We'll talk about credentials. A SSH public-private key pair is used, typically RSA, typically 2048 bits. The public-private key pair is very secure. Once you have a connection, then use that connection to set up a reverse tunnel. On that tunnel, you can use any check you want. You can communicate with the remote machine. You can copy files to the remote machine. You can do your updates with Puppet from the central server on that remote machine without fooling with any logins or agents or anything. If you need it, especially in a Windows environment. Although I must say that after doing this for a few years, I learned that there's a lot of stuff that you don't know about that you can do in a Windows environment from a command line. How many of you knew you could change a user's password from a command line in Windows? Okay. For the rest of you, you might want to write that down. The net command in Windows is a gold mine for remote admin. And I'll also mention some troubleshooting tips, and one that's worth, I guarantee, is $64,000 in wasted time. All right. Secure shell. Secure shell. Secure shell's been around for a long time. Secure shell itself is a data protocol. Everybody's seen telnet in a Windows environment, right? You telnet to a router because you're inside a firewall. You use a password, you get to the router. You put in your enable secret, you can get to configure the router, etc. What's the problem with telnet? It's not secure. Why? Because everything you send goes across the wire unencrypted. If somebody's sitting there with a sniffer, with a Wireshark, with a TCP dump, they're dumping the data, they can see your passwords. It's only usable inside a firewall where you have control over the entire network. And even then it can cause problems because somebody that's not an admin might be running some tool to sniff the password. Oh, I can go play with that router now. Well, SSH replaced Telnet pretty much, probably 12, 15 years ago. It is common. It is across platform. It is available on every platform, as we'll see. And it solves the biggest security problem, which is passwords. Passwords are encrypted or passwords are actually exchanged in the form of SSH keys, which means there is no risk whatsoever to that authentication being released to the outside world. After you exchange validation, that encryption provides a confidentiality and integrity of data over any network, basically. There are some minor issues with that. That's why anybody on a like a DoD network requires an air gap, because you can still break SSH if you're the NSA and you got $45 million worth of supercomputers in the back room to chunk away on the data, which foreign governments would have. But for normal commercial purposes, that's not an issue. And then in the SSH world, when you SSH somewhere, you think, well, you're going to connect to that machine. That's typically what you're doing as an admin person. The whole key to this heterogeneous platform is using that SSH connection to run in the reverse direction, a reverse tunnel. Advantages to SSH. It's secure. Many, many years ago, SSH1 was discovered to have vulnerabilities. SSH2 was released. It's the only protocol you should be using today. With SSH2, the host identity is verified with a key pair. The user is authorized with the same type of key pair. Once that connection is established, the data that you're transmitting across that connection is also secure. It's available on every platform. It's not installed natively on Windows. You have to jump through a couple of hoops with Cygwin, but it's not a big deal. If you need any help doing that, send me an email. You know, I can send you a snippet of installation procedure. It's fairly trivial. The only trick in installing Cygwin is to make sure you know up front if you want a 32 or 64-bit environment, because the paths are going to be different. You know, one goes in program files versus program files x86. The biggest thing about that reverse tunnel is it requires no firewall change whatsoever. Assuming you have unrestricted outbound access, which is usually not a big deal. If you do have restricted outbound access, another trick that I've used in other installations is to run it on port 443. Because most firewalls will verify if they're filtering, they'll verify the URL on port 443, and unless they're comparing you to an allowed list, which most of the times isn't the case, it will allow that traffic, and once you establish the connection, this firewall doesn't know what's going on. You know, can't interpret the traffic inside that connection. And again, in our environment, active checks are the key because they make it simple. No agents, no installation, no NSCA, you don't need an NS client, active checks everywhere. And again, you can still use the GUI. In a Nix world, I'll call it Nix because I'm referring to BSD, Linux, Unix, OS X. And in a Nix world, X Windows is the window manager, and you can easily run X Windows across a tunnel as long as you forward the traffic. You know, you can start Firefox on the remote machine and watch it on your machine in the server room. That's how I use it to configure servers at client installations. By the same token, if you're running Windows, you can set up an RDP connection for the session, take it down when you're done. Just forward port 3389 on your Nagios server to 3389 on a remote machine. Our desktop to the Nagios server, you're looking at the remote machine. So you can get a Windows environment on any platforms too, still. But most of the time, you're not going to need it. Let's talk a little bit in detail about SSH. We've talked about keys. The standard identity verification key is 2048 bits today. It used to be 1024 before some, I'm not sure if it was revealed NSA could do it. Of course, they can probably still do it anyway. But there were some cracks for 1024-bit keys released about 5 years ago. So everybody jumped to 2048-bit keys pretty quick, which is the standard today. It really doesn't make too much difference. You just give it a key link when you generate it. With that SSH key, the forward connection works, again, for hosts behind the firewall. A reverse connection or a tunnel works for anywhere else on any platform. That tunnel then, once you establish it, in other words, it's a tunnel because you log in from the remote machine to the Nagios server, and then the traffic is connected from the Nagios server back to the remote machine. That's why it's called a reverse tunnel. It gives you connection to the remote machine from your Nagios server without any access to it whatsoever. You don't have to be able to touch that machine as long as you have a tunnel up. The way a forward connection works, you must have a static IP. Anybody deal with customers that are like Soho businesses? They've got dynamic IPs from AT&T or something like that, or whoever your DSL provider is. And what's the problem with a dynamic IP? Yeah, I mean the IP changes and your host key doesn't verify anymore. Every time that IP changes, you have a new host key, and you have to accept that host key from that IP. It doesn't work very well. That's a big advantage to reverse tunnel in that kind of environment. It also requires an open port. Even if the router has a static IP, you have to have an open port through the router or the router/firewall, so the traffic reaches the internal machine that you want to get to. Even if you use an agent, agents are still designed for forward connections. Most of them are. And again, I was really interested to see the NCPA earlier yesterday afternoon when he was talking about, well, you can automatically configure it for passive checks, and it will phone home and report its results without any action on the server's part. That could be something interesting. The only downside of that is you still do not have access to the machine if you need to get to it for troubleshooting. A reverse tunnel is defined as packet encapsulation using a network protocol. The data payload is then encapsulated in a delivery. Payload being TCP/IP layer 3, actually be 3 or higher. You've got a network connection, you have a TCP connection, it is sequencing packets. If you get a packet out of order, it will resequence it on the receiving end, and you get a handshake so that you know each packet is received. That's the payload protocol. The delivery protocol can be different things. L2TP, standard VPN, Microsoft VPN, layer 2 tunneling protocol. You have other VPNs that run SOCKS, and then you have SSH, which is what we're talking about. And again, that reverse connection is a connection from the client to the server where the traffic is routed from the server to the client. There's 2 major steps and 3 minor steps to establishing an SSH connection. The first thing you have to do is start the session. The remote machine says, hello, I am here. You exchange a server key. The remote machine says, hey, do you like me? The main server says, yes, I like you. At that point, you generate a session key. The session key is the key that is used to encrypt the traffic. It is not asymmetrical. It is a symmetric encryption. It is moderately fast. That way you don't take one heck of a big performance hit when you run an SSH connection. But to generate that session key, you must have authenticated the server first. Then you can switch to encrypted mode. And at that point, you exchange the user or client key. If that key verifies, if there is a and again, in this case, we'll have a picture here in a second. The remote machine sends a user request to the server, sends a encrypted hashed packet to the server, encrypted with the private key on the client machine. The server decrypts that hash with the public key that has already been placed on the server. If it is okay, the server says, yes, I have the right key. We can continue talking. Here's a nice little picture of it. The client says, hey, server, are you there? Yes, I am here. We agree on a cipher and a compression scheme. There are some options which we don't need to worry about, like SSH2 and different compression schemes. Then the server key is exchanged. The server sends a public key. The client uses that public key to generate a session key and encrypts using the server public key, sends that encrypted session key back to the server. At that point, all traffic is encrypted. That's the basic operation of SSH to get a secure connection. Once you have a secure connection, then you do the authentication. The client sends its public key to the server. The server encrypts a random number using that public key, sends it back to the client. If it can be decrypted, the client sends its unencrypted random number to the server. If it matches, the server says, yes, I recognize you. Yes, that key pair is valid. And the connection proceeds. It sounds complicated, but it's really not. We don't ever see it. But the point to take away is there's 3 keys involved. The server key, the user key, and the session key. Session key we don't care about. We're going to talk about the server key, or the host key, and the user keys. Those key pairs use a public-private key pair, standard SSH. Those key pairs are used to identify the machine and the user. Normally in today's world are 2K-bit RSA keys. There's two parts to them, a public key and a private key. The private key is what always stays on the source machine. I'm sorry, the private always stays on the source machine. The public key is what you copy to the remote server to authenticate that connection. SSH keygen is the normal utility to create them. Now, how do those credentials work? That host key, again, verifies that the host server is the same one to the machine before. When you first start a connection, you will see a message on the screen. This host key is not, the identity of this host cannot be verified. Do you wish to accept this key? You say yes. It's saved to the local key chain on your machine, local set of keys on your machine. The user key verifies the user is authorized for the connection. Okay. Why don't use passwords? First reason, there's nobody sitting there to do it. If you were to automate it, you'd have to have the password there in a file in clear text. Granted, you can tweak permissions on it, but it's not worth it. It's not worth fooling with it. And it's much less secure than actually using the key. On a Unix box, Linux box, BSD box, AIX box, keys are kept in the home directory by user, /home/user/SSH or .ssh. In the Linux world, dot means that directory is hidden. It doesn't show up in a normal directory listing, but it is very common. If you start dealing with this, you will see it all over the place, even on the Windows side when you're using Cygwin. The default name of the key is ID_RSA. The public side of that key is .pub. On a Windows box, install Cygwin first. Takes 5-10 minutes. Pull it from the Cygwin site. It gives you a emulated bash shell environment on the Windows platform. And the best thing about it is all of the standard Linux utilities are there. SSH, we use it for backups a lot with rsync. rsync on Windows under Cygwin. We typically use a default directory install of C program file Cygwin. The thing to note is the Cygwin world, if you will, is totally contained under that Cygwin directory. So the home directories are Cygwin, home, username, .ssh. That's the worst thing that gets people in trouble that I'm trying to show how to use it. Cygwin is an app to Windows. So everything in the Cygwin world lives under the Cygwin directory. If you want to get to the system drives from the Cygwin directory, you would use a path of /Cygwin/ or cygdrive/C or D or E or whatever if you want to get back to the Windows drives. Key names are still the same, .ssh, ID_RSA, and ID_RSA.pub. On OS X, it's very similar, except the home folder is /users instead of /home. All right, let's talk about setting up a reverse tunnel. No, it's not Greek, it's not German, it's not Finnish. It's just a command line. You can get it off the slides, or if you need help, if you want any of these files that I'm talking about, shoot me an email. I'll be glad to send you a copy of it. The basic SSH command, SSH, it's sort of automated in my fingers. I've been using it for so long. If I want to go somewhere, the first, where am I going? And I look on the screen, I have SSH up on the screen. So SSH is the base command. -F means do not run in the foreground. I don't know why it's not -B. The key one down here is reverse operation. Normally, if you run SSH, it'll make a it'll give you a connection you can type. Well, Run in background and no remote command means you don't care about that. You're not issuing a command. You don't want a connection. You want to use it for something else. So F and R are the keys. If you want to run X Windows, if you're talking to a Linux or Unix or BSD or AIX or Solaris machine, you would add a -X. Assuming there was an X Windows server running on that remote machine, you would be able to use X applications from the remote machine on your local machine. The next part of the command. You have to tell it where you're going. Remember here that this command is being executed on the remote machine. So it took me a long time, many years ago, to mentally get a handle on what's happening. I tried to simplify it here for you. This means that on the Nagios server, remember here we're running this from a remote machine, I want to connect from this port on the remote machine using localhost to this port on the local machine. Normally think of the connection going from here to here. No. In this case, you're going from here to here. Then you have to provide authentication. Username on a remote machine. Again, the remote machine is a Nagios server. Remote host, host name or IP of the remote host. Okay. I'll show you in a few minutes here. There are some other options you can add when we can actually talk about the command. So that's the basic SSH command. Or I'm sorry, we do have another slide here. How many of you use port 22 for your SSH connections? Okay. Every script kiddie in the world knows to do a port scan on port 22. One of the first rules of security is to obscure your access, security by obscurity. About 15 years ago, we standardized on SSH port of 2206. I guess it was 7 years ago. So I think it was 1996 when we did it. All of our SSH connections run on port 2206. No script kiddie is going to find that in a normal scan because normally they only scan the first 1,000 ports, 0 to 1024, because those are the standard remote services. By putting it on 2206, it's a non-standard port. It's not used by any other common service, and it means that it's moderately secure from hackers and script kiddies. I can't count the number of Linux machines I've logged into, and the script log is just full of login, Joe, John, Harry, Bob, just script kiddies running password guessers, user ID and password guesses against the machine on port 22. Haven't seen one yet on port 2206. So security by obscurity is one other trick or clue I can give you. In our Nagios world, since we have over 75 machines on remote sites, those remote sites are controlled by customers, which, while we trust them, we don't necessarily trust that their environments are totally secure. We need to be able to disable a machine, one of those remote machines, if we have to. We do that by using what's called an identity file. Now, remember the SSH key pair. You can tell the server what key to use by supplying it with an option -I. And I'll show you the commands here in a few minutes. So we use a separate key pair for each remote server. We generate them when we configure the remote server, and we use them in the connection string when we connect to that remote server. All right, 3 steps to create a tunnel. First thing you want to do, connect from the remote machine to the Nagios box, create the tunnel. There's a host key and a key pair involved in that step. Second step, make sure it stays there. Make it permanent. On a Unix machine, you put in a cron job. Simplest way to do it. Every hour you check the tunneling, make sure it's up. If it's a critical machine, you can do a cron tab entry, check it every 5 minutes. You can also use autossh. Autossh is this neat utility that's been around for a while, and it will both set up the tunnel and monitor it. You give it 3 ports. You give it the port to run the tunnel on, you give it a port to check the tunnel on, and a port to look for the response on. On the OS X world, you use Launchpad, launch control. Again, I've got some examples here I'll show you in a few minutes. The third step is set up the authentication to use the tunnel from the Nagios machine. And that involves the user key. Okay, so there's 3 keys involved in these 3 steps. You got 2 keys involved in creating the first one, a host key and the user key from the remote to Nagios. And then you've got the key from Nagios back to the remote. Now, it's getting too complicated for you? It's really not that bad. That's why I try to simplify as much as I can with various steps. So the first step, connect that remote machine to the Nagios server. You want to create a key pair on the remote machine. Do a key gen, type the key, cat the key, connect the Nagios server, add it to your authorized keys on the Nagios server, then test it. That sets up authentication from the remote machine to the Nagios machine. On a Windows machine, it's very similar, except you use Cygwin. And when you're doing it, you might want to add autossh, bash, perl, rsync. And then, once it's installed, use the same process to create that authentication from the remote machine to the Nagios machine. OS X, the same as a normal Linux, Unix, or whatever. Not that hard. Second step, make it permanent. You can create a cron job. I'll send you this file if you want it. Just shoot me an email. Don't worry about copying it down. But basically, use all of the variable information in the file. That way, you can configure it. You can push it out with Puppet if you want. All you do is give it a port number. And we talked about changing the port. Create the link. Here's the base SSH command. Remote port, local port, username, remote host, login port, identity key. Let's finish that. That is one line. I broke it with a backslash here. No, it is just one line when you're typing it. That cron job, next step. If it's running, if not, start it. This is bash script. Look for the command to be running. Remember command we defined up here? This is the command, SSH, etc. If it's there, do nothing. If it's not there, run it. If it is there, we log in to the Nagios box, and we try to connect back to your box. If we can log into the Nagios box and connect back to our box, it's working. If it's not working, we kill what's there and restart it. The cron job is a simple way to manage a process. Again, you run every hour, every 5 minutes, and whatever you think you need for your remote environment. In Windows, you install autossh as a service. Again, I can send you examples if you want. There's a command in Cygwin called cygRunServe, which installs a command, -I, autossh. I'm going to call it Nagios link, executable. Here's the 3 ports I was talking about. Your monitor port, your reply port, your port to use, login port, credentials. That's how you set up the autossh server to run under Windows. Once you've created it, use the services.msc plugin to set your restart options. Restart options, there's 3 levels. Restart if fail, restart if fail, restart if fail. Set your credentials. There's a user created when you install SSH on Cygwin called Sig Server. Normally that works. Or you can use a created Nagios user, or you can use a local administrator, depending on how you're using your Windows Server for authentication. Sometimes it's a nightmare to figure out with a domain user or a local user or whatever, so that's something you may have to figure out what works. In OS X, you can use autossh also, or you can use a cron tab or cron job. OS X is trying to deprecate cron jobs, though. They are not guaranteed to be here forever. They're trying to get rid of them. So if you do have OS X boxes, you can install autossh with Homebrew. Here's the command, exactly the same. And you can launch, or you can install as a system service with launch CTL. And here's the file example. Very similar to the other ones, except it's what you have to use in an OS X environment. Next step, set up your Nagios authentication. So you can connect from Nagios to that remote machine and actually use the tunnel. Almost the same process we use is copying the key from the remote to Nagios. You copy Nagios key to the remote machine. You look at the public key, you highlight it, go to the remote server, edit authorized keys on the remote server, add it on the end, and save it. These are the commands for using Vim. If you want to use whatever your favorite editor is, it's fine. I always install Vim because of syntax highlighting. You know, if I'm using it on a file, Vim has so many templates for syntax highlighting, it just makes it so much easier to read. Once you have SigRun Serve installed, in the Windows world, it's exactly the same. And it's exactly the same in the OS X world once you have the tunnel up. So, think about what we just created. Any BSD, Linux, OS X, Unix, AIX, Solaris, we now have a working SSH connection to that machine. I can SSH from the Nagios server to that machine at any point in time. I can monitor that connection as the parent of all those checks on the machine. If the connection's up, we're fine. If not, we'll send out an alert. Need to troubleshoot it. You can use it for active checks. You can use it for anything you need to. You can admin that machine. That's a very powerful structure. And again, if you're using domain, if your servers are domain members, excuse me, you may have to jump through some hoops to figure out what's going to work in your environment. I'm not a Windows expert. I've got a guy that does it for me, and sometimes he can't figure it out. So what are we going to do with those tunnels? Well, we can use any kind of check we want to out there. Here's a local check, which everybody's seen. Local service, hostname Nagios, root partition, check local disks. If you want to check via SSH, you have to add things like an IP address. You may want an alias, icons, check command. Reverse check is very similar, except you have a few extra parameters, like possibly a port number, possibly a user. Let's see, next slide. Yeah. You may also have a private key to pass along. Here's a comparison of them. Actual commands, check local disk. Check by SSH. And reverse check. Again, the major difference being you're specifying the RSA key here with a local user. So you use them just like local machines with a minor variation on the check commands. So what do you do for plugins? Well, we kind of take the simple route. I build a VM for each platform we're working on. I compile them. So far, I've had good luck with plugins compiling both on many flavors of Unix, Linux, and Windows under Cygwin. There's a few minor tricks to get your configuration set right, but it's pretty well documented for each of the plugins. And again, we run all those platforms today. It's not a big deal. Although I might want to comment that based on some of the information we talked about yesterday, you know, the Windows 7, the new services, you know, we're probably going to be looking for some migrations on the checks for Windows because the format's changed so much. I haven't done any research on that at this point. I don't know what the status of the core Nagios plugins are for the Windows services. But in any case, you can, with a reverse tunneling, use check NT. You can use any check you want over that tunnel. You're not restricted to an agent or NS client or NCPA. If you need a GUI, it's still possible. If you want to go to a Linux machine or a Unix machine, and if you want to run an X application, be sure you have the -X in the tunnel. And then when you connect across the tunnel, make sure you also use the -X. That will give you X forwarding on the tunnel. Example, Firefox, there's two dashes there, --, no dash remote. If you connect to a remote Linux machine, you run Firefox, you tell it -- no dash remote. Firefox will run on the remote machine and display the screen on your machine. It took me a while to figure it out many years ago, and that is about the simplest way I've ever seen to go do a router admin or launch a, you know, we use StoreGrid on a lot of our systems. You know, launch the admin panel on that remote machine with an SSH -X. I don't need a tunnel. I don't need a GUI. I don't need an RDP connection. I can just run it across the tunnel. Or if it's a Windows machine, I'll show you the command here in a second to actually launch that RDP session. What you do is set up a separate tunnel forwarding port 3389, local and remote, again, reverse tunnel. And you're tunneling 3389 on a remote machine to 3389 on the Nagios server. Works great. I do it all the time. Even from Cygwin. No, or I should say primarily from Cygwin. If I want to look at a browser on a Windows machine remotely, put up the tunnel, launch Firefox on the remote machine, I'm seeing the display on my desktop. For a sanity standpoint, I recommend you only use one tunnel at a time. Of course, if you do, then you have to have a way to kill it when you're done with it. Or you want to start the next one, you get ported in use, well, you have to go back and kill the old one. We only run Nagios on Linux, so do a netstat and grep for 3389. You can see what process is running that port. Just kill it, and then you can open your new connection. Some troubleshooting tips. I hope these help you out. Sometimes it's taken me a while to compile them. The first problem you'll see, if the key is changed, well, why would a key change? Okay. You know, a real common reason if you have a new, if it's not a static IP, the IP changes, the host key won't verify, you'll get a warning screen like this. If there was something nefarious going on, there might be somebody intercepting your traffic, in which case the host key isn't going to validate. So I've never seen that myself for something that's simple. I mean, for Amazon or Google or something like that, it might be an issue. But for our remote checks that we're doing, it's really not an issue. So if the IP changes, if you rebuild a machine, it's easy to copy the home directory and get your user key pairs. It's not that simple to grab the host key. So the host key will often change when you rebuild it. All you have to do is go in and edit your own s.ssh file. Remove it. Look for the line down here. Offending key in known host is line 5. Edit the file, delete line 5. Make the connection again, accept the new key. You're good to go. Takes about 10 seconds. You can also do it the hard way if you want to. All right. Troubleshooting checks. Let's talk about some other ones that I hope are useful to you. Anybody ever heard of tmux? Anybody using it? You need to. If you're troubleshooting checks, tmux is the golden tool for you.
The other option is screen.
I'll show you why screen doesn't work. tmux is like screen, but it's better because tmux will allow you to split the pane you're looking at. I've never seen screen do that.
Screen does split the pane.
Okay. Anyway, the whole concept is a terminal multiplexer. It enables you to have multiple terminal windows on one screen that you can look at the same time. Each one of those screens can have a different program running in it. You can be looking at the host definition, the check definition, and have a test window where you can compare them side by side. Here's what it looks like. I've got the definition in the screen up here. I've got the command, or the check definition here, the command here, and I'm testing it down here. This is the only way that I have found to effectively run a check to see where it's breaking. Now, there may be other ways to do it, but you can do the same thing for configs. You know, you can split it into 3 or 4 or 5 or 6 panes. Each pane can have a different part of the config, and you can look at one to the other and quickly isolate what's going on and figure out where the problem is. Here's some useful aliases. Nagc. You know, I don't know how many of you are actually heads down sysadmins like I am, but I would much rather type 4 characters than 6 or 7. So Nagc, or you can even shorten it if you want NC. Everybody know what an alias is? Anybody not? Okay, an alias is basically a shortcut you can save in your environment, so that I just type nagc and it executes that command. Same thing for nag home. On this machine, the home directory for Nagios is varlib Nagios. It's a BSD box. Nag hup. You know, it isn't easy to reload the Nagios configuration. Now, what I don't know yet is how Core 4 is going to affect that, because I've heard of some problems that you can't reload effectively in Core 4. You have to restart it. I'm not sure I like that, but we'll have to test it. But here's a one command, nag hup, that will look for the current Nagios command, pull out the PID, awk for parameter 1, and then kill minus hup. It will reload the Nagios process if it's running. Nagq, query ports. This alias will sort and show me all open ports currently on the machine. These are the ports that there was remote tunnels used coming in. So I can log into the machine, do a nagq, and see how many we've got. I can count them. Excuse me, I can count them. I can do a nagq and grep for a specific port to tell me if that port's running or not. Short way to do your Nagios verification, nagv. User estimate Nagios minus v with your config file. Any user can run a nagv. Root has to do the hup. All right, here's some extra resources. SSH Authentication. There's a lot of good information on Wikipedia. Again, if you'd like a copy of these files, shoot me an email, tell me what interests you, and I'll be happy to send it to you. You know, we've got standard files we use in our installation scripts that, you know, there's nothing proprietary in them. Thank you very much. Questions?
I use Mod Gearman in my remote location, and I wanted to have a way to do the SSH tunnel between that server and my home or the master server. I want to be able to have the SSH tunnel pegged up all the time. Is that better than having the checks go through the tunnel in your config check?
I have never compared it.
Okay.
I just heard about Mod Gearman a couple days ago.
Okay.
So the only downside to running the active checks is load. You know,
Right.
if you've got 2,000 or 3,000 checks running, it might be too much load for a single machine. So, you know, in which case using a client or using agents might be something that you would do to offload, or possibly setting up hierarchical Nagios machines like one of the chaps talked about yesterday. I do not know anything about Mod Gearman. Sorry. In our environment, we're running 100 hosts, probably 1,000 checks, so it's pretty stable.
All right, guys. We're actually running a little over on time right now, so if you have any questions, he will be making appearances for a little bit while longer
Yeah,
until
I'll
he
be here.
jumps on his plane after lunch. So how about a nice big round of applause one more time? Leland Lammert.